snowball is melting in such a way that its surface area decreases at the rate of 1 square inches per minute. How fast is the radius decreasing when r equals t, 3 inches? So we have here the surface area of a sphere, and that is 4 pi r squared. Getting the rate of change of both sides respect to time. So the rate of change of area with respect to time, and that will be 8 pi r dr dt. So we need to find the rate of change of the radius with respect to time, and that will be the rate of change of area with respect to time over 8 pi r. And substitute the rate of change of area. So in this case, it is decreasing, or this will be negative 1 square inches per minute over 8 pi, and the radius is 3. So this will be negative 1 over 8 pi times 3, and that will be 24 pi. A manufacturer estimates that the cost of production X units of a certain item is C is equal to 40x minus 0.02x squared minus 600. How many units should be produced for a minimum cost? So for minima, let's get the first derivative of the function. So C prime will be derivative of 40x, that will be 40, minus the derivative of 0.02x squared, that's 0.04x, and derivative of 600 is 0. And the first derivative must be equal to 0. So 0.04x is equal to 40. Dividing both sides by 0.04, and that will be x equals 1000. The equation normal to the curve y equals sine x at 0, 0. So using the formula of the point slope form, y minus y sub 1 is equal to m times x minus x sub 1, where m is the first derivative. So y equals sine x, and the first derivative is cosine x. And when my x is 0, so cosine of 0, so that will be equivalent to 1. So that will be y minus y1 is 0. It's equal to m is equal to 1 times x minus 0. So this will be y is equal to x. But that is the equation of the tangent line. We need here the normal line, and the normal line is the negative reciprocal of our slope. So this would be negative 1 over 1, and this should be negative 1. So this one is only tangent line. To make it normal, my slope here should be negative 1. So this would be y is equal to negative x, or that would be x plus y equals 0. What number will be greater its square by the minimum amount? So let's say the number is x, and its difference with its square should be the greatest. So let's say that is y. To get the value of our x here, so we need to find the minimum value of y. So this will be a maximum minimum problem. Get the first derivative. This will be 1 minus 2x. And first derivative must be 0. So 2x equals 1. Dividing both sides by 2, so x will be 1/2. A kite flying 100 feet above the ground, moving in a strictly horizontal direction. So let's say this is my kite. And then it is 100 feet above the ground. And it is moving in the horizontal direction. Let's say that is x. So if it is moving, the rate of change of x with respect to time, that is 10 feet per second. How fast is the angle between the string, let's say this is our s, and the horizontal changing when there is 300 feet of string out? So we need to find the rate of change of this data. Let's say the horizontal is x, the vertical is y. So using our tangent here, so the tangent of theta will be y over x. And y here is 100. Or this will be 100 x raised to negative 1. Get the first derivative of our expression with respect to time. So the derivative of tangent, that's secant squared theta. And then d theta dt. And this will be negative 100 over x squared. So we need to find the value here of our d theta dt. So using our Pythagorean theorem, so we all know here that the sum of the squares of our legs here, that will be x squared plus 100 squared, and that will be s squared. And then we all know that secant squared theta is also 1 over cosine squared theta. So that d theta dt will be equivalent to negative 100 over x squared times cosine squared of theta. So what is the cosine of theta here? Cosine of theta is adjacent, that's x, over hypotenuse, that's s. And the square of the both sides will be x squared over s squared. So we can change it into x squared over s squared. We can cancel out our x squared, so this will be negative 100 over s squared. And when the string is 300 feet, so we should change it into 300 and then squared. So, and then we have here our value of dx dt. So we should change it into dx dt once more. So we should multiply it with the dx dt, which is 10. So what is our value here? So this is negative 1 over 90. What is the allowable error in measuring the edge of the cube that is intended to hold 8 cubic meters? That's the volume. If the error computed in the volume is not to exceed 0.03. So we all know that the volume is edge cube. So for example, the volume is 8. It's edge cube, so the edge will be 2. Then we need to find the error. So when the volume is edge cube, getting the differential of both sides, so dv will be 3e squared and then de. So we need to find our de here. So differential of the edge is dv over 3e squared. So dv here, that's 0.03 over 3, and our edge is, what's the value here? So this will be 0.0025. What value of x maximizes y on the function? Y squared plus y plus x squared minus 2x equals 1. Getting the derivative, this will be 2y y prime plus y prime plus 2x minus 2 equals 0. And to maximize, y prime should be 0. So we can cancel out this one and this one. So 2x will be equal to 2 and x will be 1. A spring whose normal length is 10 has a modulus of 12 pounds per inch. That's our K. calculate the work done in stretching the spring from 12 inches to a total length of 15 inches. So our formula for our work will be integral of f dx from x1 to x2, where f here, as we all know, k is equivalent to f over x. So meaning our f will be kx. So k is 12 times x and then dx. And our x1 and x2 are deflection. So our x1 will be the change in our length initially. So it became 12 from 10. So that would be 12 minus 10, and that would be 2. And for our x2, that's the final change in our length. So the final length is 15, and the natural length is 10. And that would be 5. So the limit will be from 2 to 5. What is the work done by our spring? That would be 126 inch pound. A bicycle travels along a straight road at t o'clock. It is t squared miles from the end of the road. Compute its average velocity. So average means it is the change of distance over the change in time from the 1 o'clock mark to the 4 o'clock mark. And S here, that's t squared. So that would be 4 squared minus 1 squared. And the change in time is 4 o'clock minus 1 o'clock. So answer will be 5 miles per hour. And using the same question, compute its instantaneous velocity, and the instantaneous velocity is the first derivative. So t squared, so the first derivative will be 2. We need to find the instantaneous velocity at 3 o'clock. So when t is 3, so this will be 6 miles